We've talked about solving by graphing, finding the point of intersection. We've talked about solving by substitution and finding the x and finding the y's. And more to put that up. And now we're going to do another way. We're going to do elimination can be addition, subtraction, or it can be you can have to multiply first before you add or subtract. So today we're just going to talk about ones that are kind of already set up to add or subtract, and then they'll be easy to solve. So what happens is we have these two systems, right? 2x plus 3y, or we have this one system, excuse me. Negative 2x plus 5y equals 13. Now, the way that you know how to solve them is A, we could graph it and find where they cross, right? Or we could solve one of those for one of the variables. But if you look at that system, that's going to be kind of hard to get one of the variables by itself, right? Because, I mean, if you look, for the x, I would have to move the y and divide, or vice versa, right? Because both of them have coefficients on them, both of them. It'd just be a lot of work. Then I'm going to end up with some fractions. It's not going to be very, very nice. But as I look at this, I notice that two of the variables are the same. Do you see that? The two. The x's are the same, right? Mm-hmm. These two are the same value. It's just that one's a negative. Well, what we can do is we can add the two equations together. Okay? So I can do this and put a big plus mark here and add the first equation to the second equation exactly the way it sits. And it's already lined up nicely for me. All the terms are, the like terms are together already. Okay? And I'll give you some steps in just a minute. I just want to kind of show you how it works first with one that does nicely. If I were to add this, what is 2x plus negative 2x? 0. That cancels. What is 3y plus 5y? And then 11 plus 13 is 24. We're adding them because I noticed that the x's were the same. Okay, so if I added it, it canceled the x's out. And remember, my goal at the end is to find out what does x equal and what does y equal. When they cancel out, it gets y by itself so I can solve. How would you solve that for y? Divide by 8.
You want to do that when it's the same like that?
Yeah, I'm going to give you some steps and some general. I just kind of wanted to show it to you first. I understand it's a little confusing, and then give you some steps on how we recognize that we can use. But remember, this is only half the answer. If I wanted the other half, if I wanted the x, what would I need to do? Plug in. And it doesn't matter which equation you use, and that's any kind of system you're solving. Once you have half the answer, you plug in to find the other half. So I'm going to just show you on this equation. Y is 3. So I have 2x plus 9 equals 11. Can you solve that for x? Yeah. Subtract 9. And x equals 1. So the question was, well, that's all well and good, but how do you know you can do that, right? So I'm going to give you some steps how you recognize that you can use elimination, but I wanted to show you what elimination was because it's not, to me, it's not quite as logical as substitution. Substitution makes sense that I solve per variable and plug it back in. But elimination, you might not understand about the adding of the two equations. Huh? No, we won't be graphing these. All right, here's what you need to do. The first thing you need to do is you want to look to see, will any variables cancel out? if you were to add or subtract. And I'm going to put a little example here that we can kind of answer these questions as we go with the example that's on the side. And I'm going to hold up after I put this and give you a second to catch up with me. Two equations. So if I'm talking about adding or subtracting, do any of the variables have the same coefficient? Okay, that's essentially what I'm looking for. Coefficient is the number in front of the variable. Okay? Don't worry about positive or negative just yet, but do any of the variables have the same number in front of them? The y's do, right? Do you see that? The y's are the same. So in this case, yes, the y's are the same. Okay? Well, before you subtract or before you add, you want to make sure your equations look the same way. Okay? So in other words, your x's and y's are on the same side. Okay? So make sure both equations are in standard form. What is standard form? It's the x and the y together on the same side, okay? These are both set up nicely for us in standard form already. Do we all agree? Did you see the difference? Remember we got slope-intercept, standard form, and point slope. This is standard, okay? So first step, look to see will any of the variables cancel out if you were to add them together or subtract them. In other words, do any of the variables, either the y's or the x's, have the same coefficients? Okay. Then, if they do, you want to go ahead and manipulate your equation and make sure that it's in x's and y's and then the number. Now you're ready to do the algebra part. You want to either add them or subtract depending on what you need to do to make the variable cancel. All right, so we're going to stop here a minute to make sure we all understand what it is we're supposed to do. If I added these two the way they are now, 4x plus 5x would be 9x. 3y plus 3y would be 6y. So it doesn't cancel. That's what I'm saying. So instead of adding, I need to subtract. Okay? And then it would cancel. So if I subtract here, now when you subtract, be very, very careful because you have to subtract everything. Okay? So it's 4x minus 5x. What's 4 minus 5? Negative 1. What is 3y minus 3y? 0. Those cancel. Now be careful over here. 2 minus negative 2. 4. Now, if it helps you, and you can't, does anybody have trouble subtracting that way? Because you can do same, change everything. And then you can add it. That's going to confuse you? Okay. Okay, we'll just keep on subtracting. Keep on subtracting. All right, if negative 1x equals 4. All right, so now we've done step 3. Are we all in agreement? Okay, so we need to solve for whichever variable we have. Well, if I have negative 1x equals 4, divide it by negative 1. 4 divided by negative 1 is what? Now, the rest is not new stuff. The rest is what we've been doing. Once you have half the answer, you use it to find the other half of the answer, right? That's right. So now step 5 is going to be plug in. Plug in to find the other variable. It does not matter which equation you use. You can use whichever one you like best.
Are they always going to have the same one that has the same numbers?
These we'll get later on the ones that don't, that we'll have to multiply by something to make them have the same number. But right now, for today, while you get used to adding them together, they will. Yeah. All right, so if I've got x equals -4, which one do you want to plug into? The top one? All right, we're going to plug in this one. So 4 times -4 plus 3y equals 2. -16, Zamoria, plus 3y equals 2, right? Add 16 to both sides. So, this solution is -4, 6. X equals -4, y equals 6. These take practice. These, to me, were always the hardest when I learned systems. I understood substitution because substitution made sense to me. This makes more sense to you?
Yes.
I like this other one.
Yeah, I understand this.
All right, so these are set up nice and easy for you right now. Look at this one.
What? Can you do -y2? You add forward.
And I'm showing you now. That's what I'm showing you. What if there...
What if you subtract x to get
All right, so before I even start rearranging, because it might be easier to do substitution on it if I had the chance. Before I rearrange, I want to look, and I want to compare some variable values. I want to look at the x's. Are the coefficients on the x's, are they the same? No. How about the y's? The y's are. So that means yes, and I need to go ahead and go to step 2. Okay. So I want to make them look the same, because before you add them together, they have to look the same. They have to be in the same order. That is the key. What? Yeah. Write this one down. Y'all wasn't writing this down? Oh. All right, so I'm going to take this one, and I'm going to rearrange it, because remember, I want the x and the y together on the same side, right? So this piece needs to come over here. Do we agree? How do I get it to go over there? Subtract 3x. Okay? Now, I'm going to completely rewrite my 2 equations. Yeah, I'll get to the top. Right now, I'm just trying to make the 2 purple equations look the same. Okay? So now my top equation is 8x minus 4y equals -4. I need the x to come first. Like, they have to look exactly the same. If the x comes first in one, the x has to come first in the second one. -3x, positive 4y, and it equals 14. Okay. All I did was I took this second equation, I moved the 3x over here, and I rewrote both equations. Does that make sense to everybody? No, Zamora? This 3x, I didn't want it over here anymore because when I add them, the x's, the y's, and the numbers have to be together in the same column. So it's gone now from this side. Instead it's over here, right. You can't subtract them because this one's got an x and this one's got a y. So I just left them and kept them there. Okay? Now go ahead, what?
You gotta add.
Because this is a positive 4y. Yeah. All right. So the question now is, do I add or do I subtract to make the y's cancel?
No, you don't subtract. If you subtract, it's going to be -4 or minus.
All right, well, let's look at it. We're looking at the y's, right? If I add, what is -4y plus 4y?
0.
And that's what I want. So I have to add. If I subtract, I'd have -4 minus 4, which would be -8. Okay, so I want to add, what's 8x and -3x? 5x. We said these cancel. -4 plus 14. The hard part's done at this point. Okay, I've got half my answer. I need the other half of my answer. And so, yes, Christian, I'm going to plug in to find the other half. Pick an equation. It doesn't matter which equation you use. Mm-hmm. Yep, you'll get the same answer. First one. 8 times 2 minus 4y equals -4. Go ahead. 16. Yep. So subtract, because right now it's being added, so I need to subtract it because it's positive there. That's after it. You have to look at the first sign. If it's positive, you subtract it. If it's negative, you add it. What?
Oh, we did add it.
All right, the 16's gone. I have -4y equals -20. How do I solve that for y? What's -20 divided by -4? Very good.
Okay, but then that's like what we did last time.
All right, I'm going to work the first one with you. Yeah. Yeah. The nice thing is, through the sections in your book, so the first section it says, solve the system by elimination. By addition. Then the second one says use subtraction to solve by elimination. And then the last one, you have to figure out, do I need addition? Do I need subtraction? And you also have to rearrange them like we did in the last one. Okay? The first two sections, you shouldn't have to rearrange any. All right? Do you want me to do one you have to rearrange, or do you want me to do one that you don't? Okay, let's do that, and then also that you have to rearrange. I'm looking at number 19. This is on your homework, so make sure you copy it because it's one done for you. All right. -x minus y equals 14. X equals 5y minus 38. I'm doing a hard one with you, so you don't have to. All right, so the first question is, are any of the coefficients the same?
No, they ain't no numbers on there.
But if there's not a number, what's there? 1. So yeah, the x's are good, right? So I need to rearrange this second equation. Yeah. So I'm going to take this y, and I'm going to move it over here. So because it's positive, I've got to subtract it, right?
Yes, subtract 5, yeah.
And actually, I'm going to put it on this side of the x because that's the way the first equation's written. The first equation is x and then y, so I'm going to do this one. I want it to look exactly the same as the first one. All right, so the first one's negative 1x. I'm going to rewrite them over here so it's nice and neat so you can see it. All right, so Zamora, what's that second equation? You were saying it. 1x minus 5y. That's right, negative 38. You were right. So now the question is, do I need to add them or do I need to subtract them? I need to add them. When the signs are opposite, add. When the signs are the same, subtract. These are opposite, so I'm going to add. I'm proud of y'all, actually. I was kind of nervous about this lesson.
I mean, I like to do that. You too.
Negative 1y and negative 5y give me what? But it's negative 6, right? Negative 6y, because they're both negative. What is 14 and negative 38? Y'all got that. It's negative 24 for the sake of time. How do you solve that for y? What do I do? Divide by negative 6. So y is, dun, 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 what is it? 4. Positive 4. This is a negative divided by a negative. Yes.
Does math ever get boring?
No, I love it.
You love it?
Now it's gonna get boring for me because it's a lot of work.
It's always something new to learn. All right, am I done? No, because I've got half the answer. The other half, Zaya, the other half is x. How do I find it? Plug it in. Which one you want to plug it into? Does it matter? No. Y'all always go with the first one. We'll go with the first one. Negative 1x minus 4 equals 14. Yeah, I plugged it in for y.
Oh, it is, yeah.
Yeah. How you solve it for x? Add 4. So the 4's are gone. Now I have negative 1x equals 18. What do you do? Divide by negative 1. What? That's right. Tell me what you think about solving by elimination.